opposite. Actually, it's going. It is the opposite side over the hypotenuse. Now, when I say the opposite side, it's again all relative to where you're standing at. You're always standing at an angle. You're never standing at a side. You're standing at an angle. Now, that angle that we're standing at in this instance is angle x. So angle x in our triangle is right there. Okay. So let's go label those sides. You just told me opposite over hypotenuse. Go label out opposite and hypotenuse in that triangle then. You're standing at an x. That's that reference angle we had talked about yesterday. So where's the opposite at? I got three sides up here. Which of these three numbers is my opposite side? 3 is. Thank you. So I'm going to replace 3 with what? Opposite. You told me the hypotenuse. Which of the other ones are considered to be the hypotenuse? Definitely 1. Well, hypotenuse is the easy one, right? It's always across from what?
The 90 degree.
The 90-degree angle, right? Okay. Cosine. What's the cosine ratio we said yesterday? Adjacent over hypotenuse. That's the next part of SOHCAHTOA. The cosine and the order of it appears, that's the ratio, adjacent over hypotenuse. So as Yante reminded us, okay, so adjacent is relative again, relative to where you are standing at. That's your immediate left, your immediate right. Okay, so as you're standing at angle x, what's my adjacent side up there? Yeah, it's my 2. Okay, so that's my adjacent. Technically, the hypotenuse is an adjacent. Okay, but hypotenuse takes priority. That hypotenuse gets that designation. Okay, we're all good there, I think. Maybe not outside there. And then the last one is tangent. And what do we say about tangent? Opposite over adjacent. That's the TOA part, okay? And again, you don't necessarily have to the mnemonic device TOA tells you the order of the numerator over the denominator. So opposite over adjacent. The opposite side over the adjacent. If I can spell adjacent. I did not spell that right, did I? I spelled it right the first time. The second time. The adjacent. Now, yesterday we didn't have a chance to talk about it, I don't think, but today we'll get more than enough opportunities. On all these 3 right here, I wrote sine of x, cosine of x, tangent of x. When we write these equations out, you always write it out as the trig function of what angle you're standing at. So as you see, I wrote sine of the angle you're standing at. So in this case, it's the sine of angle x. Yesterday, I wrote the sine of angle A, I think is where we were standing at, or the sine of 45 degrees, or the sine of 30 degrees, wherever you were standing at, okay? So, there we go. With that in mind today, first thing I would like you to do is take a quick minute, and based off what we just did, we did a little bit of this work already yesterday, go write me the first row, okay? On the first row, go do me sine, cosine, and tangent of angle T. Sine, cosine, and tangent of angle T. Just do the first row. I'll give you a quick minute. Try that out. T is my reference angle. 16, 20, 12. What's my opposite side then? Thank you. What's my adjacent side then? And then the first one we should always really know is the hypotenuse, which is, once you know those things, writing up the ratio should be relatively quick. So what is my sine ratio then, somebody? Okay, yep. Wait, so let's start with the original ratio. 12 to 20, right? Sorry, it's in my head there. 12 to 20, right? And then 12 to 20 reduces it by what? Reduces by 4, right? And this reduces down to 3, 5. Okay. Sorry, I was having a brain fart there. I was expecting 12 to 20, which is then 3 to 5. That's it. That's all I need from you. Cosine ratio is, thank you, which reduces again by that factor of 4, which is 4 to 5. Thank you. And last one is? I think it's 12 to 16, right? You good, Brianna? Okay, 12 to 16, which reduces by, which is? We got to make sure we're good here first. If you cannot do that, you're done for. If you can't set up opposite, adjacent, hypotenuse and write those ratios, you're going to be screwed. All right. Now go do the next one. Go do G. Okay. We didn't get a chance to do this one yesterday because everything was standing at the same angle. But now we're going to go stand at the other angle in there. What's going to happen is you go stand at G. What happens, Eva?
It like changes a little bit.
What changes a little bit?
The sine and the cosine.
What is switching up here then?
The adjacent and opposite sides.
There you go. Thank you. So you're standing at angle G now. That's now your reference angle. And because of that, what she pointed out, something flips on you then. It's all relative. Everything's relative to where you're at. So as you're standing there at now angle G, what is now considered the opposite? The perspectives change, right? Your 16 is considered to be what? Right. So that's what you got to watch out for. And once you realize that, nothing crazy now happens. And 12 is now the, again, if you did the practice yesterday, I think you got a little bit, again, more work with identifying those opposite adjacents. Now the hypotenuse, does that change? So then run it across, okay? Once you've identified everything, it's the same thing we just did. Sine is now what? Okay, 16 over 20, which I heard is what? 4 to 5. Cosine of G is what? 12 to 20, which is what? 3 to 5. And last one is what? Tangent of G, which is 16 to 12, which is 4 to 3. So your calculators have two modes on there. It has something called degrees and radians. Some calculators might have something called radians. That's more of an engineering thing. But degrees and radians. And if you're in the wrong mode, you're going to get a number. It might sound for you like it's okay, but it's definitely not. As you roll into Algebra 2, pre-calculus, you're going to flip back and forth between the two modes. But right now in geometry, we are going to work in degrees, okay? And physics, same thing, but we're going to work in degrees. Your calculators all default to radians. If for some reason, as Spencer said, his batteries crapped out, as it powers back on, don't be surprised if sometimes it flips back from degrees to radians. I will say more with the older models like mine that are the batteries, not the charging ones. Every once in a while, I don't know, it just flips. So you need to occasionally check to make sure everybody's calculators are still in the same mode. My backups that I gave to Nevaeh, those usually always stay on degree mode. But the 84 models, those are the ones, I've done it for enough years, for whatever reason, every once in a while, they'll flip on you. So be careful. If you're getting some negatives, you should not ever get negatives, okay? You can't have a negative angle. In radians, things get weird, but we're not in radians yet, okay? Okay, so how do we change this over to degree mode? Or make sure you are in degree mode. For some reason, you might already be in there. If it's an old calculator from a sibling or a rental. Okay, we're gonna click mode. Nevaeh, you should be good, but you have a mode button on yours, I believe, too. Okay, mode brings you to the settings screen. Go down just a bit, and on mine as well, my default is radians is highlighted. Go click down until you see radian degree. And you want to make sure you click over and you hit enter. Hit enter, degrees should now be highlighted. If it is not highlighted, you're going to have a bad day. Okay? Everything's going to be working into the radian mode. You got to be in degrees. And our backups should always be in degrees. Those always default to degrees. But the 84s will be in radians. So if you're in degrees, you should be solid. The 83s, I know I got some 83s out there. Same deal. Okay. Now we'll find out very quickly if you did not do that as we do this first one. All right. Hit second mode to quit it out. Back to your calculator screen, and let's do some trig. All right, number one. Let's write the equation. When I get that first quiz out there, this is a 3-pointer. I'm looking for 3 things here. The first thing is the correct equation. Go stand at that angle, label out me the 2 sides there. Figure out what trig function you are using. So stay at, what is it, 25? Stay at the 25, label out me the 2 sides. What's my 2 sides I got up there? Okay, there you go. Label it out. I heard adjacent and hypotenuse. Based off of my ratios up above, what trig function is that? It's cosine, right? What did you say? Did you say cos? Oh, okay. I thought I heard cos there. All right. It's cosine, right? Oh, you said cos there, Yante? Oh, I don't know. I still don't like Eva, but I still like Yante. All right. Okay. Okay. So cosine, right? So here's what I'm looking for. The correct way to write this. Okay? We're going to write the cosine. You chose cosine. Cosine of the reference angle. What angle are you standing at? You're standing at what? 25 degrees. Okay? Is equal to, well, what's the ratio for cosine? Adjacent over hypotenuse. What is that in this instance? Right, x over 7. That is the equation we're looking at. That is your starting equation. That's your first point. I got to make sure, hey, are you doing the right thing? Now, we got to solve it out. Okay, this is going to look a little funky because we've never worked with something like this with cosine, right? No big deal. You never worked with radicals before, but we've worked with them, so give me some time. All right, don't overthink this. Think about your equation skills. How would you solve for x? How you can get x by itself? Right, just pause for a second. Don't write this down. You know, what if we had something like this? 5 equals x over 7. How do you solve for x? Multiply by 7, right? To get rid of the 7 in the denominator, that gets x by itself. You would multiply both sides by 7, and then you say what? 7 times 5, 35, right? It's the same idea. So what we're going to now do here is, all right, we're going to multiply both sides by what? 7. Now, when you do that, I want you to absolutely put that 7 on the other side out front. Put it out front. Don't put it accidentally behind the cosine of 25. So what we're going to have happen is what? These 7s are going to cancel. And then we're going to have 7 times what? The cosine of 25. Okay? X is by itself, didn't it? X got by itself. X is what? 7 times the cosine of, it's the same thing we had here. 7 times 5. It's just 7 times the cosine of 25. Okay, this is what we call right here. We call this calculator ready for. This is where we want to be. Go to your calculators now. Type that in. It is in calculator ready form. It is ready to type in. And we're going to find out if you will are in degree mode. So we're going to type in 7 times, I don't need to put the times sign because 7 cosine means 7 times 25. And everybody's calculator, when you hit cosine, opens up a parenthesis, right? Yeah. Close the parenthesis, hit enter, and let's see if we all get the same decimal. If you did not get that decimal, you are not in degree mode. Anybody not get that answer? Cool. All right. In trig, unless the directions state otherwise, typically side links all go to the nearest 10th. Okay, that's our default. In this instance is what? 10th, yes. Which is what? 6.3. That is our default usually for trig, rounding it to nearest 10th. Okay. So that's my 3 points right there I'm going to look at. one for the original equation, one for calculator ready form, and one for correctly rounding it. Okay? One down, let's go with another one. You just found that first one, let's go with another one. Go stand at that reference angle, guys. 65. Label them out. What do we got? Opposite and adjacent. Which one's my opposite? Alrighty. And my adjacent is 11. You got a label. Cool. What trig function? Tangent. Yeah. All right. Let's write the equation. Tangent of your reference angle. So tangent of what? Yep. Equals what? X over 11, right? So that variable is going to move on you. It's not going to always be. Actually, this is the numerator. My bad. I'll shut up. X over 11. X over 11. Opposite over adjacent, right? There's only so many ways we can do these where you're going to realize, oh, what we got to do again? Solve for X. Multiply by 11. There's my first point for the equation. You're going to realize, hey, I got to multiply by 11 again. You're going to multiply again. And where's that 11 going to end up with? Out front of tangent, right? That's it. It's not a super complicated thing. We've already started laying the groundwork for the trig ratios. Go to your calculator. 11 tangent 65. 65, close that parenthesis. Check me as well. 23 point what? 23.6. That's it. 23.6. Let's roll to the next one. Stand at that angle. Stand at that reference angle. What do we got? Okay, opposite and hypotenuse. Which was my opposite? And hypotenuse is pretty obvious, isn't it? Okay, of the three trig functions, what do we got? Well, what you got there, Yonsei? 23.6? Okay. Opposite and hypotenuse means what? Sine. So for the equation, make sure it looks correct. Okay, as we write that out. Opposite over hypotenuse, right? So here's the thing. At some point, I always have somebody want to write it like that. I don't know why, because I've never written like that. Besides, right now, to tell you not to write it like this.
Why is it 65?
Because I'm talking about not to write it like this.
Yeah, but like, why is it 65? There shouldn't be
It's a 78. I don't know why I wrote 65. But yeah, I don't know why. But on that, okay, it should be a 78. But on there, I think I looked right here. That's why. The last one. But on there, for whatever reason, I always have a handful of people not at all paying attention and writing that angle out front. Never ever. We always keep talking about sine of the angle, cosine of the angle. So this is my hey, don't be whatever you want to put there. Okay, don't be dumb. Okay, pay attention. Let's write it properly. Sine of 78, sine of that reference angle. And then, after that, solve it out. Okay, what are we going to do to solve it out? It's another multiply, right?
Yep.
All right, this is getting boring. And we're doing another multiplication of 11 times the sine of 78. I don't. I was paying attention on that previous one, I guess. 11 times the sine of, what was it? 78. Close that parenthesis and check my rounding. What do we got? 10.8. Now, usually at this point, again, you're like, oh my God, that is pretty easy. It is relatively straightforward. Let's flip it on you.
Oh.
Yes. All right, let's go down to the next one. Do the same thing. Nothing's changing until we start solving. All right, it's not crazy. Just stop whining. There's no whining in math class. Okay? No, there's not. Okay, let's go to the next one. Stand at that reference angle.
Oh, that's the same.
What's that? There you go. 35 is what? 7 is what? And x is what? Meaning what trig function? Sine of 35, and Deontay said is 7 over.
Yep.
Okay, so the x is not always in the numerator. Okay, this is the one students again will mess up on. So let's point this out. All right, we haven't done much of anything with that throughout the school year, and you really wouldn't, okay? Because it does lead me into something later on down the road, but we're not. That's more of an algebra 2 thing as well. How do we get rid of that x out of the denominator? So let me pause here with you. Okay. How do I get x out of the denominator? It's the same way that we did up above from the other ones. We got to get x out of the denominator. And to get x out of the denominator, we are going to do the same process. We're going to multiply both sides by x. By doing that, what's going to happen here? These x's are going to do what? Cancel out. And what we've done is we moved them out of the denominator here and moved it to the other side up in the numerator, right? So what we have now is what? 3x equals 7. We can work with this now. We've seen this before, right? How do we solve for x now? Divide by 3. And when we divide by 3, x is going to be what? 7/3, I guess. Okay? So we're going to do the same process. We're going to multiply by that denominator. And when we do that, the x goes over to the other side like you stated. And then what we're going to do is we're going to divide not by 3, we're going to divide by that trig function. Wherever that trig is there. Sine 35, cosine of 20. It's going to look weird, but we did up top there. With multiplication, we're going to have division happen then. Okay? So I'm going to use the space up above because it is going to get a little messy. I got some space right there. So what do we got? The sine of 35 equals 7 over x. And like I said, we're going to multiply by that x. We got to get it out of the denominator. And by doing that, again, I always bring that out front. I always bring it out front. Again, what happens to those x's? Cancel out. Right. It's going to look weird. Why? Well, we've never done it before until now. And think of that sine of 35 as just a 3, just a 2. Just how do you solve for x now? There's multiplication there. And what's the inverse of multiplication? It's division. It's just a number there. So what we're going to do then is, divide. Boom. That is what we now call calculator ready form. Instead of multiplication of 7 times the sine of 35, we're going to have 7 divided by the sine of 35. Okay. Now go to your calculator. That's my calculator ready form. And as you type that in, you better make sure your finger did press that division key. I don't know how many times, again, I've gone through and I've looked at students' calculators. They're like, hey, I got written division. I'm like, yeah, but you didn't type in division. So if your calculator did not hit that division key, all right, or you think it did, make sure it actually shows division on your screen. And what was it? Sine of 35. Okay? So 7 divided by sine of 35, nearest 10 says 12.2. Okay? Oops, you said 2. That's as crazy as it gets. Okay? The variable ends up in one of two places there. The numerator or denominator, it's getting multiplication or division. Let's go with another one. What do we got? Sine, cosine, or tangent? Tangent, says Eva. Why do we have tangent? Because 13 is the, x is the, right. Ideally, you start to see those trig ratios pop up very quickly then. The more of these do, they're going to pop up quick. Okay, tangent of the angle, 42 degrees, is opposite over adjacent. You're going to get to know them very quickly, probably by tomorrow. You're going to see, oh, it's multiplication. Oh, it's division. And then, oh, it's inverse. That's tomorrow. Okay, shut up. All right. So as we do that again, there's no whining, Eva. There's no sighing in math class.
I would never.
You do that all the time. I know. All right. Again, I'm going to show you the algebra with it. Again, we got to get that x out of the denominator, right? There's a big side back there. Okay. X's are gone on the right. We moved them to the left. But again, that tangent of 42, it's just multiplication. And the inverse multiplication is division, right? And there it is. That tangent of 42s are going to cancel. And there's that calculator ready form. X is now by itself. You have 13 divided by the tangent of 42. That's where you want to be. That's that calculator ready form. You're ready to type it into your calculator. Make sure your calculator, you got that division key. Survey says, somebody got 14.4.
Yup.
There you go. Last one there, sine, cosine, tangent. What is it? Sine, cosine, tangent. Thank you. Because 6 is my adjacent and x is my hypotenuse. So again, when I test you out, I'm looking for 3 things to get the correct equation written properly. And do you have the variable in the right location with that? Adjacent over hypotenuse. Variable moves on you. Solve it out. We've done 2 of these. And I know some of you are very much on the ball. You're going to see that variable when it's in the denominator. It solves the same way each time. How is that going to be written out when you solve it out? 6 divided by cosine of 27. Every single time. There's definitely patterns that happen with that. Do you need to show me how that solves out? No. I'm hoping you realize that it's going to keep doing that. If you need to solve it out like you did on the first 2, cool. Knock yourselves out. 6 divided by cosine of 27. Survey says. What's it say? 6.7. 6.7. 6.7. Yep, I agree with that. There we go. And that makes sense too. You get the hypotenuse. The hypotenuse should be the longest side. It is longer than 6. Like, that makes sense. Okay. All right, let's wrap this up. Flip it. We got only a few minutes here. Let's do number 5. All right, number 5 is a SAT problem. Okay, number 5. Draw me that triangle. Draw me that triangle that has that specific ratio.
Oh.
The sine of x is 3/5. Your calculator is done for. Draw me the triangle that has that specific ratio. This is an SAT problem. So think about what the sine of x equals 3/5 has to look like for that given ratio. I'll give you a second. Think about what that triangle has to look like. There's only one way that triangle can look, okay, with that given ratio. Now, how you draw it might be ever so slightly different than how I draw it, but in the grand scheme of things, there's really only one way to draw that sine of x equals 3/5. Now, I don't care how you start off your triangle. I'm going to make my right triangle like this. Did you draw your right triangle like that? Okay, cool. Most people probably do. One of my old math professors did some type of study about how people draw triangles, and a lot of people basically draw the right triangle like that. Yeah, he was weird. Plus, if you're a college math professor, stereotypes happen for a reason, right? Okay, where'd you put your variable at? The top angle or the bottom angle? I'm sorry? The bottom? Bottom? Okay. And put mine at the top.
Oh.
Don't erase it. It doesn't matter, okay? It doesn't matter. Now, it's all relative, right? it's all relative to where you're standing. In the end, it's all going to come out the same. Sine is opposite over hypotenuse. So for you guys, all right, I'll make you happy then, and I'll do it over here then too. All right, for me, this is my opposite, right? This is 3, and this is, whoops, try this again, 5. For you, this is what? Opposite, and this is my still hypotenuse, right? Find me my, what do I gotta have to do cosine and tangent? I gotta have the adjacent, don't I?
Yeah.
Go find me my adjacent. You should be able to do that immediately. This is our 3, 4, 5. We're gonna have to use Pythagorean theorem. This is our 3, 4, 5. Okay, so our adjacent side is 4. Our adjacent side is 4. Well, heck, again, isn't adjacent on both of these the same thing? Like I said, it doesn't matter where you put that reference angle. Okay, it's all relative. You still got the same type of triangle. Okay, so let's write our ratios out. Cosine of your triangle, cosine of my triangle. Pretty sure it's the same thing, right? Uh-huh. Cosine is what? Adjacent over hypotenuse. Absolutely. Tangent is what? Opposite over adjacent, which is in this case 3 over 4. Your triangle, worked out. My triangle worked out. Like I said, it doesn't matter. Just be consistent. When you stamp that reference angle, you know where your opposite and adjacents land. It's going to be still fine. Okay? SAT loves to do that with you. We're going to get a lot of practice with that in the next couple weeks. Okay? All right, I'm going to shut up now.